This module covers network speeds, Internet of Things, or IoT as we know it, and cloud computing. Cabled network speeds. A cabled network is a network that's actually involves cables from end to end. Now, obviously, the backbone of the internet that travels across the country, around the world, under the ocean, those are all cable based. So, connecting different spots geographically. And the common term we use for that is Ethernet. Ethernet is kind of taking the place of older dial-up internet connections. Dial-up used the regular plain old telephone system, or they call it POTS, plain old telephone systems abbreviation. The first internet used that as the backbone to transfer data. The only problem is you can only get but so much throughput with a regular plain old telephone system. The Ethernet that we look at today is packet switched and not circuit switched. So there's all these different packets flowing across routers and switches everywhere in your modem to your computer and back and forth. The cable networks that we use today are usually either accessed through cable internet or DSL. That kind of depends on your geographic region. DSL does still reach out to more rural areas. Cable internet is available in more newer developed areas, or at least areas where cable had already been ran, but it is continuing to be improved. The infrastructure in the United States is somewhat older, in that they adopted and laid telephone lines a very long time ago. So a lot of cable companies came after that, and now they're having to spend a lot of money to either redo their cables or basically expand. Many types of cable exist. You got fiber optic. Fiber optic is definitely used for long range communications across cities, across metropolitan areas, from state to state. Even under the ocean, connecting different countries together. And they're ran for miles and miles and miles. You've got Ethernet. Ethernet has like a maximum transmission distance of like 300 feet, and that's about it before it needs to be repeated. So you can't run that for miles. And that's an example of a regular RJ45 is the end of that connector of an Ethernet cord. And then you got coax. That's your normal cable cords. They also transmit data, cable, phone, everything today's time. Your internet service provider, or ISP, are kind of like the middleman. They purchase network access from the tier one companies. The tier one companies are the ones who own the backbone of the internet, who invested very early in the infrastructure. AT&T happens to be one of those people. That's kind of where they get a lot of their clout and money from. They actually own kind of parts of the backbone of the internet, and a lot of other companies that you probably never heard of. And then the ISPs lease access to home and business users. Most of the ISP download connections to home and business users range from like 512 kilobits per second. That's really still even the slow end of things. The original dial-up was 56 kilobits per second. And it can range up to 10 gigabits per second. So remember kind of the conversion. There are 1,000 kilobits per second in a megabyte, or a megabit, sorry. Then there's 1,000 megabits in a gigabit. So 512 kilobits per second would be like 0.5 megabits per second on average. And then you see all the ranges there up through 10 gigabits per second, and even 100 gigabits per second being tested for businesses. Again, each one of these, depending on your needs, sometimes come with data caps as far as like how much you can download per month. Some don't though. Some have unlimited depending on your internet service provider. Some of those are like Suddenlink, Greenlight, AT&T, Spectrum, which used to be Comcast, or I forget who they used to be, but Comcast is another one. Xfinity, you've probably seen commercials for those. Really just depends on your geographic location of who offers it to you. Now, mobile network speeds, those are based off your cellular networks that you used to just get make phone calls off of from your mobile devices, but they also offer internet to mobile devices now as well. That's offered by like Verizon, T-Mobile, AT&T, Sprint, and so on, depending on who you have. But those four companies are the main ones that kind of own the backbone of most cellular networks, and then some of the little guys kind of lease it from them. Mobile networks are classified in generations, not necessarily speed. Now, each one does get slightly faster, but it isn't directly related to a speed. For instance, 1G really didn't offer any internet available. 2G did offer some internet, but it was around 100 kilobits per second, so it's like 0.1 megabit per second. It made text messaging possible and picture messaging possible. 3G offered connection speeds of around 42 megabits per second max, but around 8 megabits per second was the typical rate. 4G offered connection speeds around 300 megabits per second, but the typical was around 60 megabits per second max. 4G is kind of like the widely used one right now. 5G is coming on the horizon, and it offers speeds from 1 gigabit per second to 10 gigabits per second. Again, the typical speed is not known yet because it's not in the full swing of things and full implementation, but it will be soon. And again, each one gets faster and faster, as you can see, but it's not directly related to speed. The G stands for generation, not gigabit or anything. And then, we get accustomed to it. So obviously, as each one increased in generation, we were able to offer different types of devices that use mobile cell networks, like your cell phone, some tablets that have that enabled that you could get a data plan for. The sophistication of apps, the sophistication of communication and what they're capable of doing is dependent on the network speed that they are offered. So obviously I cringe when my phone goes to 3G because it gets so slow, but at one time that was the fastest that was available. So I'm sure we'll feel like that about 4G, or as they call it, 4G LTE, soon when 5G rolls out completely. And these are just some of the typical, if you had versus 4G, 3G, and 2G, what you were doing, how long it would take. So accessing a typical web page, with 4G, it takes like half a second. 3G might be like 4 seconds. So slow, right? But in today's time, 4 seconds would be like an eternity to try to download a web page. And then you can go all the way back to 2G. It takes like 3 minutes for it to come up. Sending an email without an attachment, you can see there some of the big ones, like downloading a music track. You see there 2G is like 7 minutes. And then even downloading an application, it's like an app. Take you like 40 minutes to do that. 3G about a minute, 4G about 8 seconds. Network speeds. The more you pay, the faster your download connection speed. Or is it? So you always have to think about what your needs are if you're a business or at home for the network you're paying for. According to an article, the fastest ISPs in 2017 in PCMag.com, 80% of Americans had no idea how fast their connection was supposed to be. So you were paying for something, and again, a lot of times these cable companies or telecommunication companies like a CenturyLink or Suddenlink, Spectrum, they just kind of bundle it all together and offer you a discount. So it's really a lot of people don't know exactly what speed they got. They just know it works when they need it, right? Or it doesn't work when they need it to. According to the same article, 71% of those respondents said they felt their connection speed was as fast as their ISP promises most of the time. The problem with that is, and I've had cable internet for many years through Suddenlink and now Spectrum. Broadband Ethernet for cable companies is called like a party line. So they run a lot of bandwidth out to one geographic area. And if you get on the internet at, let's say, 1 o'clock in the morning and you pay for 100 megabits per second, you might get even a little bit over 100 megabits per second. You might get 110 megabits per second or something like that. But if you try to get on it at 3 o'clock in the afternoon when all the kids get home from school and jump on Netflix and online gaming and stuff like that, you probably will not get what you pay for because there's so many people pulling from that same line. Now, DSL, on the other hand, is dedicated to your house. However, most DSL companies don't offer the higher download connection speeds that cable companies are able to offer. So it's kind of like a trade-off sometimes, or picking or choosing. And some people don't have the option of choosing because there's not many providers in one area. Now, continuing with network speeds by country, these are kind of the ranks from 2018, and you can kind of see there if they changed or not from the previous year in 2017, if they went up or down. And this is the average speed. So this is not the fastest speed available. This is average. So you got to average in the fastest with the slowest and how many people have each of those types of internet. So it comes out to an average. So the average in megabits per second for Singapore was 60. Sweden 46. Denmark used to be number one, but they kind of bumped back down a little bit. And you kind of see down all the way down there at the bottom, the USA is around 20th in the world at 25.86. Now, what goes into this? Why wouldn't again, we live in the United States, so I kind of felt the need to put that one in there. They were all the way back at 20, because our country is very far ranging. Some of these countries, like for instance, Singapore, Sweden, Denmark, Norway, they are the size of like a state in the United States. So their infrastructure does not have to span so far. So they're able to update it for a cheaper cost than, let's say, the United States has to do it in kind of sections. Also, certain companies are owned privately versus some internet is owned by the whole government. And the age of the actual infrastructure plays into a fact as well. Again, as I was saying, the USA has a older infrastructure than some other places. Some companies are spending a lot of money to upgrade it, but again, it's section by section, and it kind of depends on where you live. So again, it just kind of depends. But all of those are different factors. Akamai is a network and cloud computing company that also does network research. They provide kind of like a quarterly state of the internet report for networks around the world. And their Q4 2011 report stated that Washington, D.C., Ohio, Alaska, Missouri, Georgia, Iowa, Illinois, Colorado, and Texas were among the states with the most customers with connection speeds under 256 kilobits per second. So that's like 0.25 megabits per second. Basically, you have a really slow connection. So that's just a little bit better than dial-up. It's approaching dial-up speed. So why is that? Well, you got to think about some of the age of the infrastructure. You got to think about Texas is a really big state, a lot of rural areas in Georgia, Texas, Alaska especially. I was surprised to see Washington, D.C. on the list just because it's such a metropolitan area. But then again, it's so many people, so you have to think about that as well. Internet in Eastern NC, because that's where we are, right? In middle to Eastern NC. Some of you may be in different places as well. But again, Nash Community College is based in Eastern NC, so I thought it would be interesting to put a couple of these stats in there. Excuse me. Suddenlink is offering 1 gigabit per second in Eastern NC, but is over about $150 per month, and that's just for internet connectivity. Greenlight in Wilson, North Carolina offers 1 gigabit per second fiber connection straight to your house. CenturyLink offers somewhat fast DSL internet to customers in rural areas. Just again, depends on where you are. Spectrum and AT&T Fiber offers speeds of 1 gigabit per second in Wake County. That's where I'm located. I have Spectrum. I used to live in Rocky Mountain. I had Suddenlink and enjoyed them for many years as well. Google Fiber is coming to RTP in the Charlotte metro area, and it's kind of already there as well. And then if you ever need to test it, Google has their own today. And then speedtest.net is a good website to test your current download and upload to see if you're actually getting what you pay for. The network backbone, as we referred to a while ago, is owned by these tier 1 companies. It's obviously very, very fast because its sole goal is just to redirect traffic everywhere. It's not really to deliver it to an end user or anything. 100 gigabit per second connection was revised and implemented in March of 2011. Field tests were done, and some businesses like, the large ones, Amazon, Facebook, all these companies that need it because they have so many users would benefit from that. Now, obviously, that'd be probably way too expensive for us and would be an overkill for most of the stuff that we do today. But the more and more we evolve, the more and more 4K, 8K streaming we do and stuff like that, it does take up more and more. They're really large files that we're trying to stream in real time. The network registry for North America has also exhausted all available IP version 4 addresses to companies. So now you'll start to see a lot of the IP version 6. So IP version 4 was like 192.168.1.1 or something like that, right? IP version 6 is a much longer address, and instead of dots separating it, it's actually colons. And instead of numbers only from 0 to 255 in each little section, it's actually 4 numbers or letters in each section, 0 through 9 or A through F. So it's a lot different. Network speed calculation. So this is just an example. If downloading a 10 megabyte file at 5 megabits per second would take you about 16 seconds. You can kind of see the conversion there because you do have to convert between bits and bytes and stuff like that. This example can drastically slow down as the file size gets larger or the connection speed decreases. So if you've got a 10 megabyte file you're trying to download and you have a 5 megabit per second internet connection, take you 16 seconds. The file sizes today are creating a greater need for faster internet connections, and we want it in real time. We don't want to do it asynchronously. We want to do it synchronous, right? We want to watch live TV. Like for instance, with Spectrum, I'm able to watch TV through an app instead of getting a box because it's free. So instead of paying a box monthly fee. So kind of think of some of the other reasons why network speed is so important today. I'm sure you can probably think of a lot. The highest network speed ever at a sustained transmission rate was 186 gigabits per second, a data rate equivalent to downloading 100,000 Blu-ray movies in a single day. So that's kind of the highest, but again, that was a field test. Now, our homelands are local area networks. We set up and have wireless routers or switches to set up a home LAN because, of course, we're past the days of having one computer and that's it. We've got wireless, we've got phones that we can connect to the Wi-Fi instead of using our data plans, multiple computers, printers, TVs, all types of smart devices, refrigerators, everything, alarm systems. So the new wireless standard is AD. It kind of just came out. It offers 7 gigabits per second of throughput speed. So that's all the total devices that you've got in your network. It operates on a 60 gigahertz frequency radio wave band, which sounds great, but there's a trick here. The higher the frequency, and this has nothing to do with the speed. This is like the radio wave if you did like long range or short range. 60 gigahertz is very short range. It basically, even though it operates very fast, it only stretches about 9.8 feet away from the wireless router itself, or it starts to get slower. So again, it's not good at going through walls or overcoming other barriers or obstacles like metal and sheetrock and stuff like that. But it is really fast, and it is good for streaming like 4K and 8K video. But most devices don't support it yet. So even though you can get a new wireless router, remember, you're only as fast as your slowest device. So even though the wireless router might be fast, if your device is very old and slow, the network interface card on your device is not going to magically get faster. Now, widely used and still fast wireless standard is 802.11 AC. So AC, if you have an AC router at home, it can be well over 1.3 gigabits per second in total bandwidth. Operates on a 5 gigahertz radio wave, so it does pretty good in distance, but you could also backwards compatible it with 2.4 gigahertz if you need it to go farther. 2.4 gigahertz is one of the frequencies that cordless phones, the old cordless phone in your house, if you still got one, operates on, or 5 gigahertz, so it's very similar. Most models have separate bands to also help balance the networking load, and the Netgear Nighthawk, and they have an X10 now, is actually capable of much more than that. These are just some examples of AD or AC routers. Again, they can operate on 2.4 gigahertz, 5 gigahertz, if you're backwards compatible with N and G. Those were the previous standards. And when planning your home or business wireless network, you really have to think about your layout. What are the obstacles? Like, do you have a lot of metal or anything like that that could deflect the signal backwards? The distance of the devices from your wireless router, and so on. So even the total amount of devices you'll have streaming or connecting at one time. Now, a mesh wireless router is kind of new on the market for the last couple of years. It's a regular, like a regular wireless router that we saw before, creates one large internet bubble for all the devices to connect to. Wireless mesh routers create many overlapping internet bubbles. So a mesh wireless router is good for larger homes or businesses with multiple levels, outdoor entertainment spaces, and you can kind of walk around and not even notice that your phone is switching from one internet bubble to the next because they're all interconnected. And the more nodes, as you see there, they have like multiple nodes, multiple devices of the mesh wireless routers. The more of those you have, the larger space you have to communicate seamlessly. And you can walk between one or the other. Your phone will never drop connection, or whatever device you're on won't ever drop connection. It's really good for large areas, especially with like outdoor entertainment spaces. They've got ones that are made for outdoors and so on. Now, piggybacking off of that, the internet has become so fast, and it's kind of the demand of the Internet of Things. So the internet has evolved from the basic connections of web servers connected together by cables. That's all it used to be. A bunch of web servers that you could connect to and download, view your ESPN scores or whatever it is, right? Now it's more of a connection of billions of devices that all have internet connectivity and share our information, data, locations, statuses, etc., and has launched a call for a uniform platform as far as sign-in, storage, and connectivity between accounts. You've probably seen that. They're all trying to work together now. And the Internet of Things kind of connects your smart devices together via internet. For instance, your smart home thermostats, it could relay a signal, and again, all these smart devices are connected to the internet. If your smart home thermostat relayed a signal to your smart vents, so they have vents that have internet connectivity in your home, to open and close to redirect airflow around your home to help energy efficiency. So that, again, depending on what the temperature is in each room, it can sense that, and it relays and shares information between the smart thermostat and the vents. Another example would be your smartphone communicates with an alarm system that can lock the front door from your phone using internet, or it can arm or turn off the system from your phone, or it can even turn on a lamp connected to a smart outlet. So they've got smart outlets that connect to the internet, and it can shut off or allow power through that to turn on or off a lamp or something like that. So how is all that possible? All the devices, power outlets, vents, thermostats, whatever it happens to be, are connected to the internet and controlled by apps or some type of software. Now, also continuing with that, as the internet speeds increased and continue to increase, cloud computing becomes more of a viable option. Cloud computing is the delivery of computer services, shared resources, software, and information, basically over a network. So think about an electricity grid delivering power to customers. It combines the resources from areas over a network based off of internet protocol. So the typical cloud computing that we think of is like Google Drive, Dropbox, where you can upload and download your files wherever you are. All you need is internet connection. So you don't have to carry around a flash drive anymore or anything like that. Types of cloud computing, you can have application, platform, or infrastructure. Again, application, that's more like sharing apps across, and it's kind of similar to the virtualization we talked about a few modules ago, where you're kind of virtualizing all this stuff and storing it in the cloud. So you're able to download it from anywhere with internet connectivity. Now, again, you have to have some type of cloud client. That's like you accessing it like on your smartphone. You got to have some type of cloud application that's stored on the back end, and you got to have some type of platform and infrastructure to deliver it and host it. So all those things kind of work together. Now, you've got different deployment methods. Public is the traditional mainstream cloud computing. They're dynamically provisioned and allocated. It's usually stored on somebody's third-party provider. Can offer upgrades to the free versions to a paid version. The only problem is you don't own it. So technically, when you store it on their stuff, you kind of are storing it on somebody else's server. So technically, they kind of own it too when you do that. So you got to be careful. Community cloud shares infrastructure between several organizations. Security, again, might be a different community concern, either managed internally or externally by a third party. It kind of can spread the cost, so it's cheaper, but again, is still the privacy concerns. A hybrid cloud are usually two or more that are separate but bound together. It usually kind of tries to split up the cost for users, offers more bandwidth. It's hard for two or more private clouds to kind of know another cloud to connect with though. So again, security's still into place. The only truly private one is the private cloud, and it's usually monitored internally, not available to just anybody or any device even. So again, but the bad part is it does attract criticism because the end company or user still has to buy, build, and manage it. So it is a lot of capital, a lot of upfront cost, and things like that. Now, again, some of the cloud computing providers are like Amazon Web Services, Dropbox, iCloud, Google Cloud, like Google Drive and things like that. Even Docs and all that is based in the cloud. VMware, that's if you're trying to do it yourself. And then Rackspace is one. There's tons of them out on the market, though, that you can download. Open Cloud, Own Cloud. There's tons of them out there. Now, concerns with cloud computing has always been privacy. You've probably heard many instances of people hacking into people's stuff that's stored in the cloud. Even an instance such as the NSA working with AT&T and Verizon, which recorded over 10 million phone conversations between American citizens in the mid-2000s, which kind of caused a lot of uncertainty amongst, privacy advocates and the greater powers that it gives to telecommunication companies to monitor user activity. And you kind of wonder what they do with it. As with privately purchased hardware, as far as abuse, hackers posing as legitimate customers can purchase the services of cloud computing for, bad reasons, basically. This includes password cracking, launching attacks, and actually in 2009, a banking Trojan virus illegally used a popular Amazon service as a command and control channel that pushed software updates and malicious instructions to PCs that were actually infected. So you kind of have to weigh out and think about all of those things. Again, network speeds have allowed the Internet of Things and cloud computing to exist and will continue to increase and even get faster as we have more and more computing needs that involve the internet and we get ever connected. However, you do have to think about some of the privacy, abuse, and things like that that go on as well.